5, 6, 7, 8, 9. Yeah, I know, Max, I can count. Okay, so where does the marginal revenue curve go? We've never drawn it, right? But we know the rule. Let's use a different fancy color. It has the same intercept as the inverse demand curve on the y-axis, but it has twice the slope, or the way I remember it, it cuts the x-axis halfway between 0 and where the demand curve intersects the x-axis, right? So start at the same point where the inverse demand curve comes out of the y-axis and make it cut the q-axis halfway between 0 and wherever the demand curve intersects the q-axis. This here is the marginal revenue curve. Isn't it beautiful? This is my marginal revenue curve. Okay. Let me see if we drew this right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's right. It cuts exactly halfway. So let me ask you a question. I seem to say this a lot because my 5-year-old also says the same thing now. Let me ask you a question, Dad. I know. Should we go for ice cream or cake? Both is the answer. But the point here is for $1. Does it ever make sense to produce more than 5 units in any state of the world for this monopolist? I know you got to raise your hand for the $1 though. Yeah. Why? Now you're overthinking it already. All right. So what happens if I'm going to the right of 5 units? Is my marginal revenue greater or less than 0? Yeah. So if you increase output, and remember, it costs you to produce output, and your total revenue, the total amount of money you take in, is negative, like decreases, would you ever produce there? Never, right? You would never produce anywhere where increasing output actually leads to less total money taken in. So the monopolist is never going to produce ever, wrong pen. Monopolist never produces here. Why? Right? To the right of these 5 units right here, as you go up, marginal revenue goes negative, and that means as you sell more units, you take in less revenue, you take in less total money. It doesn't make any sense ever to produce there. Okay. I don't have any cool things. I left my backpack, and I want to give away more stuff, but I don't think I have anything cool to give away. Let's check the wallet. Is there anything worthwhile in here? Nope. I can give you a signed business card. That's the only thing I've got worth giving away, but that's worth negative money. So assume I'm setting up a reward, a big one. How about an IOU? That's something that'll work. IOU for $5. Are you ready for this one? IOU $5. Okay, here's an IOU. For $5, what else happens at this point here, halfway between the origin and where the demand curve intersects the quantity axis? This is old news. If you want the IOU for $5, you got to raise your hand, though. It's a hard question. What happens at the quantity, right, of $5 on the demand curve? Oh, right there. What? I kind of want to give you $20. That was the perfect answer. Here you go. Cash that in next time. All right. What happens at that point? The demand elasticity, price elasticity of demand right here, is exactly 1. Right? So the price elasticity of, if you go back in your notes like 10 lectures, when we derived price elasticities, we said the price elasticity of demand is exactly 1 at quantity halfway between the origin and where the demand curve intersects the x-axis. We also showed that over here, we're relatively inelastic. And here, we're relatively elastic. Okay? So what does this mean? This is amazing. Your intuition is screaming, right? Because monopolists are evil. They're definitely going to produce in the area of the demand curve where things are relatively inelastic. Well, will the monopolist ever produce in the area of the demand curve where things are relatively inelastic? Never, right? Never, because his or her marginal revenue is actually negative there. So the first takeaway message here is the monopolist will only ever produce in the portion of the demand curve that's actually relatively elastic. So the monopolist is going to produce somewhere here, right? Anywhere else it makes no sense for the monopolist to produce, because if he or she increases their output, their total revenue actually goes down. So that's pretty amazing, right? Counterintuitive results. We're 10 weeks in, and we've finally gotten somewhere that's interesting to only the instructor and maybe 2 other people in the room, but those 3 people are incredibly excited about it. But takeaway message here is monopolist only ever produces output quantities where demand is relatively inelastic in this world of these nice linear demand curves. All right? That's the first takeaway message. Have we at all talked about where the monopolist is producing exactly? No, right? We've narrowed it down to a range of output. Here it's between 0 and 5 in the relatively inelastic portion of the demand curve. But what we haven't done yet is actually drawn a monopolist with a marginal cost curve and an average variable cost curve and figured out where the monopolist produces. And guess what? That's next. The monopolist's output choice. And I should put on top of this slide profit maximizing. Okay? We don't care about non-profit maximizing firms for now. Okay, so price, output. Let's say we draw our monopolist. The way I see firms, I don't see logos of firms. All I see are average variable cost and marginal cost curves. So this monopolist has an average variable cost curve that looks like this, has a marginal cost curve that looks like this. And let's be in the short run for now. Ooh. Let's try that again. Not great, but better. Okay, we're in the short run. We have U-shaped average variable and average total cost curve. Marginal cost curve cuts to the minimum of average variable and average total cost. If this were a perfectly competitive firm, we just look up what price is, draw a horizontal demand curve, drop where the residual demand curve at price hits marginal cost, and the quantity that goes with it tells me what the profit maximizing quantity of the competitive firm is. For the monopolist, this is different, right? The monopolist doesn't face some sort of horizontal demand curve. The monopolist faces the entire market demand curve. So this is demand. So we know that this is 10 units. 1, 2, 3, 4, 5, 7, 8, 9, 10. I can still count to 10. Good. And now let's draw the marginal revenue curve. It's the same. I drew the same demand curve as before, but just to be sure, it intersects the y-axis at the same point as the inverse demand curve, intersects the x-axis at the same point as the halfway between the origin and the inverse demand curve. So the marginal revenue curve looks something like this. This is marginal revenue. All this turned out beautifully. Okay. So here's what we got to do. Monopolist is like any other old firm. Maximizes profit, where marginal revenue equals marginal cost. And then we're going to look at that output quantity is price higher than average variable cost to see whether the monopolist should actually produce. Okay, so let's do the first part, the output decision. What's marginal cost? It's this black line right here. What's marginal revenue? It's this nice red line right here. So where's marginal revenue equal to marginal cost? You can spot it. It's right here, right? This is where marginal revenue equals marginal cost. So the optimal output quantity for this monopolist here is Q star, somewhere between 3 and 4 units. Looks like 3.5 units to me. So what's this monopolist going to do, right? He's going to produce these 3.5 units, but is he going to charge marginal cost? Costs me, how many dollars here? About $3 to make this stuff. I'm just going to charge $3 for it because I'm a good guy. Does that seem plausible? Not remotely. Well, actually, we're discovering more and more good people in the world. But the point here is what the monopolist going to do is if I produce Q star units, I'm going to charge people their marginal willingness to pay, right? I'm going to look up what people are willing to pay at that quantity, and that's the price I'm going to charge. So go up, 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 and across here. This is going to be the monopolist's price. Whoa, Max, that looks pretty complicated. In fact, it isn't, right? What's new here? What's new here for now is we are still setting marginal revenue equal to marginal cost. Only for the monopolist, marginal revenue is no longer whatever market price is, but it's an actual different curve here, which is one that has the same intercept as demand, but twice the slope, right? So you just set marginal cost that you've drawn 1,000 times equal to this new marginal revenue curve. That pins down quantity. And then what the monopolist is going to do, he's going to charge as much as he can for those Q star units, and that is simply what people are willing to pay for it, which is going to be PM right here. That's the monopolist's optimal output choice, gives you the optimal price and quantity for the monopolist that he or she should produce. He could not make more money, right, in economic terms. This is the most profits he or she could ever possibly make is this Q star quantity and price combination right here, and we'll draw graphically what the profits are in a second. Before we show what profits are here, though, is we should check whether this monopolist should shut down, right? The shutdown decision is if price is lower than average variable cost at the profit maximizing output quantity, they should shut down. What's average variable cost at profit maximizing output quantity? It's this right here. What's price? It's this right here. That price is in the stratosphere, right? Compared to where average variable cost is at that output level price is much, much greater than average variable cost. Therefore, this firm should definitely not shut down. They should operate. Now, the next question we may want to ask is, what are the profits for this firm, right? Profits are total revenue minus total cost. Or if we're looking at it in average terms per unit, it's average revenue minus average total cost of production. Average revenue is how many dollars you get per unit, so that's going to be price. Average cost, average total cost of production is at that output level. You go up to the average total cost curve right here, and that tells you for that output level what average total cost is. So let's add this to this lovely picture. So this here is average total cost of producing Q star units. Now, this is price, this is average total cost per unit, and you're producing this many units. So the distance between price, which is your average revenue per unit, and your average total cost, that's going to be your profit per unit. You're producing Q star units, so total profits in this picture are the height of this box, price minus average total cost, times however many units you produce. So you can show this by shading. Actually, let's draw it in green for dollars. This shaded box right here, that's the monopolist's profits. Is this a happy monopolist? That's a very happy monopolist. You can cut this out. They have little cookie cutters in the shape of Maseratis, and then they punch out their profits and they buy Maseratis with it. No, I'm joking. Of course they don't. Who would buy a Maserati when you can afford a Ferrari? But the point here is this monopolist, the way I do it, makes a significant amount of positive profits, right? Economic profits. All opportunity costs are paid for, and then makes money on top of that. Why is he or she able to do this? What gives him or her the power to do this? We're going to talk about this in more detail. He's the only producer of a good that people want with no close substitutes, right? So some monopolists manage to make a huge amount of money. Other monopolists manage to make very little amount of money, and some monopolists actually shut down production because nobody's willing to pay what they're wanting to charge at profit maximizing output level. So it really depends on how much you're selling and how high the markup, the difference between price and marginal cost really is here, that tells you how big roughly profits are. Okay? So that's the monopolist profit maximizing output choice. Now, Max, whenever we talk about monopolists, the people talking on the radio always use this word market power. What on earth is market power? Market power has one definition and one definition alone. There are other people who try and hijack the term, but that's not legal, right? That's an economic term, and the definition is pretty simple. Market power is the ability of a firm to charge price above marginal cost profitably, all right? There's a firm that is able to charge a price above marginal cost, and if it makes money doing so, we call that market power. So let's think about a competitive firm. How does the competitive firm's price compare to its marginal cost at the profit maximizing output level? It's exactly the same, right? That was that $5 question on midterm number 2 that half of you got wrong. I'm still not happy about it. Let me ask it again to make sure you can redeem yourselves. You should never pick on your class. That's bad form, Max. But the point here is a perfectly competitive firm maximizes profits at the quantity where price equals marginal cost. So how much market power does a perfectly competitive firm have? Can it charge price above marginal cost? No, right? So a perfectly competitive firm has no market power, or in a perfectly competitive market, there is no market power. So what I'm going to show you is the ultimate application of the yoga theorem. So the degree of market power, meaning how much monopolists in our case, but you could also think about duopolists and other types of firms, are able to raise their price above marginal cost, fully depends on the elasticity of the demand curve at the profit maximizing quantity. So again, if demand is really inelastic, right, we're not talking about portions of the demand curve, but if you're facing two markets, right, one has a relatively inelastic and one has a relatively elastic demand curve, the monopolist is going to be able to extract much greater or exercise much more market power in the market that has a relatively inelastic demand curve compared to one that has a more elastic demand curve. So what are you talking about, Max? Are you ready for this? It's kind of frightening. Actually, that's not the frightening slide. I thought I had my frightening lightsaber slide next. That's after this one. Sorry, I moved them around. Okay, so first off, how could we measure market power? Right? If you're saying, Max, there is market power or there's no market power, it's important to think about, is there a degree of market power? And degree of market power, conceptually speaking, is simply measured by how far above marginal cost can a firm raise its price. Right? If it manages to raise it really, really far above marginal cost, that's more market power. If it raises its price not very far above marginal cost, that we call less market power. Now, of course, the issue here is one of scale, too. If you're thinking about manufacturing of really big, expensive things like nuclear power plants and regular power plants and airliners and so on, if their markup is $1,000 per unit, that doesn't seem like a lot, right, for things that cost hundreds and hundreds of millions of dollars. Versus if the producers of a certain medicine, that costs $5 to produce at the margin, and they're able to charge $15 or $20, right, that seems like a significant degree of market power. So the point I'm trying to make here is measuring market power in dollars doesn't seem like a meaningful measure, right? Much like the price, measuring the price responsiveness of demand in dollars isn't really a meaningful measure. That's why we came up with elasticities, which measures it in terms of percent, a unitless number. So we came up with something, well, by we, I mean we, the discipline of economists, came up with something called the Lerner Index. The Lerner Index is a really beautiful thing, all right? What the Lerner Index says is at Q star, marginal revenue equals marginal cost, right? That's the profit maximizing output choice. Now, the Lerner Index is something that simply says price minus marginal cost over price is an index that if it's close to 0 or if it's 0, right, that means price is equal to marginal cost. So if price is exactly equal to marginal cost, the numerator is 0, and the Lerner Index will be 0. What type of markets have price equal to marginal cost? Don't say it again, Max, but I will. Perfectly competitive markets, right? So markets with no market power, their price is equal to marginal cost, and the Lerner Index will be really close to 0. Now, if price is really far above marginal cost, right? Let's say marginal cost is $10, price is $20, right? So price is $20 minus marginal cost of $10. We're at $10, price being $20, we're at 0.5. That means that firm is able to charge twice the price of its marginal cost, right? So the Lerner Index here would be 0.5. So what you're getting here is you're getting a nice continuous measure of market power, which simply maps the distance between price and marginal cost relative to price into an interval between 0 and 1. All right? So the Lerner Index goes from 0 to 1. 0 means perfect competition. The further away from 0 you are, the closer you are to 1, the more market power there is in a certain market. Now, I don't know if you want to see this, but I think you do, okay? What I'm going to show you now is I'm going to show you that how big the degree of market power is, this measure of market power, the Lerner Index, can actually be directly mapped into the elasticity of demand at the profit maximizing output level, all right? So I think we're all on board here. This is the Lerner Index, distance of price to marginal cost, right, over price. But I'm going to relate this to the price elasticity of demand. And this is going to be one of the craziest pictures I will draw this whole semester. It's in fact so crazy that I'm not even going to draw it. But I'm going to walk you through it. Yeah, that's how I felt the first time I saw it, okay? Let me try and explain this to you, okay? I could try and draw it, but the one time I did, it was really messy. But I drew you text. I wrote words with it. So when you're staring at this, when you're studying for it, you'll get it. What I want you to look at for now, and I know you're all very zen, is focus on the important stuff here for now, okay? What I've got here is a market where output is on the x-axis and price is on the y-axis. I've got two demand curves, okay? Look at the solid lines only for a second. First demand curve is this black solid line here. It intercepts the y-axis at 40, and it intercepts the x-axis at 40. It's very similar to the demand curve I've shown you before, only my scale was 10-10, right? It's a demand curve with a slope of -1. Then I'm going to show you a second demand curve. Second demand curve is another solid line here, but it intersects the y-axis at 25 and has a much flatter slope right here. So what I've drawn you, ignoring everything except for the two solid lines here, is I've drawn you two demand curves, right? One is more elastic, more price elastic than the other, right? The dark black one right here, this one, the thick one, that one is less price elastic than the slightly thinner one here. I should have used color. Okay, so this is the price, relatively price inelastic. This is the relatively more price elastic demand curve. So two different demand curves. You could think of it, this is the market for movie tickets in San Francisco. This is the market for movie tickets in London. One's more price elastic than the other. All right, so that's that. Let's assume a monopolist operates in both markets, right? So there's a monopolist in London, there's a monopolist in San Francisco. They both have the same marginal cost curve. So what these monopolists do, they're going to choose their profit maximizing output level where their marginal revenue is equal to marginal cost. Since they're identical monopolists, one operating in one city, one in another one, they have the same marginal cost curve. I drew you the world's simplest marginal cost curve, all right? It's a straight line, comes out of the origin. It's this light dashed line right here. So this is marginal cost curve for monopolists operating in London, and the San Francisco one just happens to be the exact same. So I forget who was more price elastic. Was this London? Okay, this is London right here. Let's write that down. Crazy picture, huh? London, SF, all right? San Francisco, London. Beautiful places. Now, how do these monopolists decide on their optimal output quantity? They don't set marginal cost equal to inverse